Why it's so difficult to scale up a battery manufacturing plant. Let's start from the beginning. When a company have to establish a lithium battery manufacturing plant, needs to produce a feasibility study first, which include all CapEx and OpEx items and a project roadmap which should satisfy all the investors. It's not just a matter to find a place and build up a factory, but is a very tricky relationship between supply chain, product development, skilled human resources and even local authorities' permission. Recent studies demonstrate the equipment capex for 1 gigawatt-hour is about $30 to $60 million, which can reach $60 to $90 million per gigawatt-hour if we consider the overall capex of lithium battery cell manufacturing plant. The first production line, even called pilot production line, is the most painful for many reasons. Is the first exercise of the company trying to produce their product in several units per minute with automated equipment, considering a manufacturing process more or less established. Unfortunately, the pilot project is not so smooth. In the pilot production line, especially newcomers, don't have any experience about lithium #battery manufacturing and no clue about what is needed and what is the optimum to run the production. In some case indeed, we face underdesign or as opposite overdesign in terms of technical requirement for automated equipment and check quality inspection devices. Equipment suppliers must provide budgetary quotation without any clear evidence how the product looks like, or at least what is the target manufacturing process flow. In several cases is the cell manufacturer which is asking to equipment maker to suggest to them the best manufacturing process. But, based on production line layout and utilities related to each single equipment, the battery manufacturer can start to design the production layout and provide all details to dry room design and construction company, which need to design not just the clean room itself but make all calculation even for HVAC and dehumidifier. But as you can see, this is a closed loop. Equipment suppliers are not able to provide detailed equipment list and details which represent a must for #dry room design constructions. So what usually companies do is just foreseen spare space, which represent for sure additional capex but could be useful in the future for any kind of mistake or misevaluation. When the equipment arrive in the factory, all installation and commissioning activities start, and in many cases the equipment validation must be done with final and real material. But everybody know electrode manufacturing is a real pain. Only if electrode manufacturing startup phase is foreseen some months before the rest of the production line, the schedule could be smooth. Otherwise the risk is to start the cell assembly line commissioning and test with dummy material, or even stop the activities due to incoming material absence. Then the operations start, but it's too late to train the manpower. So manufacturing manager need to study in advance, during pre-operation phase, all strategy how to train the engineers without having equipment in the production plant. But as you can image, the start of production is a cold shower for everyone. After the SAT, the equipment supplier leave the production plant, and with them even big part of the knowledge in battery manufacturing. Starting from here, the battery manufacturer is alone and need to run the production by himself, trying to learn from mistake. So what's happened from pilot to mass production plant? The size is the first issue. Scale up to 20, 40, 100 GWh, foreseen huge number of equipment, very big production plants and several suppliers to manage. Have you ever been in a gigafactory of 8 gigawatt-hours per year? Is huge. Try to image 5 or 12 times more. Currently the scale-up is not so easy and sustainable for many reasons. In order to achieve 30 gigawatt-hours, the number of equipment needed is huge. JSUT to image that for a 46XX battery cell of 24R, the throughput is about 18 to 22 cell per minute. That's mean in the optimistic case of 85% OEE, about 35 winders, or in case of prismatic cell of 80R each, means over 80 Z folding machines. And this numbers belong to just one single manufacturing process. Since the number of equipment needed is huge, usually cell manufacturer move to multiple equipment suppliers, making difficult in some case the equipment integration, make training of operators on different equipment, but even triggering some differences between production lines which have equipment from different suppliers. The reason is the equipment technology, but especially quality, is not the same for all suppliers, and in average they're small or mid-sized companies which don't have the financial and manpower strength to manage this big projects. If one gigafactory can make the annual revenue of equipment supplier company for 3 to 4 years, what happen if that projects have some delays or failed for some reason? Which are the effect on equipment supplier side? Every time we talk about equipment supplier, we talk about mechanical parts, electronic components and technology device like welding units, vision camera, sensors, electrical test, helium leak tests, PLC. Maybe just few knows for some PLC the delivery time is over 35 weeks. And this is just one of several examples. The number of equipment trigger the dimension of the factory and then the energy consumption for cell manufacturing. Just to mention, dry room represent 30% of cell manufacturing electrical energy consumption. The dry room OPEX vary with the dry room volume. Number of equipment affect the number of equipment operators, logistic operators and quality inspectors, making very high the FTE required, compared to other industries. The operators and manpower must be trained and skilled to avoid to ramp up the plant for several years, just wasting a huge amount of money. If during a steady condition the overall scrap rate in lithium battery cell manufacturing plant is about 20%, in a ramp-up phase can even reach 50% or more, making the project a black hole to financial department. In average, the scale-up phase required between 1.5 to 2 years from start of production to reach steady condition and target OEE, in some cases even more. Hiring people is becoming harder and harder, even because the competitions increase, and with that the salaries of key expert engineers, making difficult and more expensive to get the best talent. In the #Lithium Battery Manufacturing System there are several inspection activities which must be done by operators due to the absence of reliable and affordable inline inspection system. This is another big pain which make impossible control 100% of the product in all inspection criteria, but even obtain a huge amount of data regarding the overall product quality in lithium battery cell manufacturing plant and correlate this information with performance during the working life. What about utilities? A thumb rule a few years ago mentioned between 50 to 65 kilowatt-hours of energy consumption for each 1 kilowatt-hour of battery cell produced. That means for 40 gigawatt-hours the factory will need 4 terawatt-hours of energy consumption, which must be satisfied by network and other renewable source. But what about the network? Are all locations able to supply this amount of energy? The answer is no. Does it foresee additional capex for the project? Yes. How we can reduce the energy consumption? The answer again belong to equipment technology, with micro-dry environment for example, but even smart manufacturing process which get rid of the most energy-intensive process, see dry coating process for example. So, honestly, it's very hard to imagine the battery industry can manage this scaling up phase with the current technology and this weak supply chain. High-speed equipment is the key to minimize production footprint, manpower and then OPEX in term of dollar per kilowatt-hour produced. Even if it sounds quite easy to obtain, we need to consider the automation can run at super high speed. Just to consider, there are equipment able to produce 1.000 gigaretts pack per minute. But the entire automation supply chain in battery business have to be contaminated by other industries where the productivities are huge, and the electronic and technology industry already developed dedicated technology able to support those speed. In the last 10 to 15 years the battery automation business didn't make any big improvement compared to cell and pack technology. So we need to move out from the comfort zone, start to talk with new suppliers and companies which have great experience in other industries but with several similarities to lithium battery manufacturing business.